Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this trigonometric equation. So we have tan x is equal to 2 times cos x. Now tan, this is equal to sine over cosine, right? So meaning tan x, this would equal sine x over cosine x. Now this is equal to 2 cosine x. Now I want to get rid of this cosine x as our denominator, so I'm going to move it to our right-hand side by multiplying both sides by cosine x. So for our left-hand side, these two cancel out, so all I'm left with is sine x. And for our right-hand side, we have 2 times cosine squared x. Now, cosine squared, this is equal to 1 minus sine squared, meaning you could write this as sine x is equal to 2 times 1 minus sine x, sine squared x, sorry. Now if I distribute the 2, I get 2 times 1 is 2 minus 2 times sine squared x is 2 sine squared x. This is equal to sine x Now I'm going to let sine x equal the variable x. Sorry, let's do y instead. So now if I substitute that in, we get 2 times y squared plus y minus 2 is equal to 0. And this means that if we plug this into our quadratic formula, we get y is equal to -1 plus or minus the square root of 17 over 4. And y is simply sine x, as we already know, so this means that sine x is equal to -1 plus or minus the square root of 17 over 4. So this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve a system of equations using the elimination method. So right here, we have our system of equations, our first equation being 4x plus 2y is equal to 14, and our second equation being 3x minus 5y is equal to -22. So to do the elimination method, we actually want to change one of the coefficients of either the x's or the y's so that they are both the same. So in this case, we have 4x and we have 3x for our second equation, and we actually want to change these two coefficients so that they are both the same. We could either do that for the x's, or we could also do this for the y's. We need to change both of these coefficients to a -5 so that they're both the same. In this case, I'm going to change the x's. So we have 4 and 3. So what is a common multiple of 4 and 3? 12, right? So we need to multiply both of these equations by a number to make 4 and 3 equal 12. So for our first equation, 4 times what equals 12? 3, right? And for our second equation, 3 times what is equal to 12? 4. And one of these has to actually be negative and one of them has to be positive, and it doesn't matter which one. So I'm just going to make the second equation negative. So now all we have to do is simply multiply and solve. So 3 times 4x is 12x. 3 times 2y is 6y. And now this is equal to 3 times 14 is 42. And that is our first equation. Now for our second equation, negative 4 times 3x is negative 12x. Negative 4 times negative 5y is positive 20y. And now this is equal to negative 4 times negative 22 is positive 88. Now I did that because now when we add these two equations, these two will simply cancel out because they're opposites. 12 and negative 12 are opposites, so when you add them, they equal 0. Now 6y plus 20y, this is 26y, and this is equal to 88 plus 42 is 130. Now if I divide both sides by 26, I get y is equal to 5. Now we are not done yet. Although we have our value for y, we also need to find our value for x. So now all we have to do is plug in 5 in one of these two equations. I'll do it for the first one. So we have 12x plus 6 times 5. We're substituting 5 for y is equal to 42. Now 6 times 5 is 30, so we have 12x plus 30 is equal to 42, meaning x has to be 1 because 12 plus 30 equals 42, so x is equal to 1. Now we can plug in these two values in our second equation to check if they are right. So we have negative 12 times x is 1 plus 20 times 5, y is 5. Now negative 12 times 1 is negative 12 plus 20 times 5 is 100. And 100 minus 12 is 88. And as you can see, 88 is the answer to this equation, meaning these two solutions are right. So that's how you solve a system of equations using the elimination method.